Yeah, from 7.
Good. So on 7 we have -4 outside. Then we have in parentheses -3xy to the third everything squared. And then we have 2/3 x to the fourth y to the third power. Good. So -4 has to wait patiently. Then we have to raise 3 factors to the second power. So this is 9, this is x squared, this is y to the sixth. Is this okay so far?
Okay.
Is it a yes?
Yeah.
Okay. So now we have 2/3 to the third. I raise 2 and I get 8. I raise 3 and I get 27. I raise x to the fourth, copy the base, multiply the exponents. Copy the base, multiply the exponents. Is this okay so far?
Yeah.
Now I have to collect the numbers. But I will simplify by 9. We always simplify before we multiply. That's the wise thing to do. So I have -4 and 1 and 8. So that's -32. And there is only one denominator, which is 3. Now I have a different rule because I have x squared times x to the 12th. Now we copy the base and add the exponents. Now we copy the base and we add the exponents. And this is it. Is this okay?
Yes, this is.
Good. Let's look at 8. Using FOIL, 3m times 4m is 12m squared. And then positive 15, but -8. So this is positive 7 mn. No, it's not mn, it's my, sorry. So 15 minus 8. And then minus 10 y squared. And that's it. There's nothing else. The same thing here, but you have to distribute 4x to 3 terms and then -5 to 3 terms. So let's see if we need help with number 9. Okay, number 10. This is a special product, very easy. A plus b times a minus b is a squared minus b squared. So this is y to the fourth power minus 49. First term squared minus second term squared. Good. Do we need to find an expression for the area that is shaded? So we will have to subtract from x times 4x minus 1, we have to subtract the opening, x minus 2 squared. Do we need any help with this one? Let me at least write it. So the area would be x times 4x minus 1 minus x minus 2 squared. So let's look at this for a moment. So here we have 4x squared minus x, because I have to distribute minus. This is 3 terms. If you only write x squared minus 4, that would be a terrible mistake. We've been discussing this for 2 months already. The first term squared minus 2 times the first times the second plus the second term squared. So I continue, 4x squared minus x squared plus 4x and minus 4. And you have to present everything in descending order, combined like terms. 3x squared plus 3x and minus 4. And this is how we have to enter it. And this is the area that is shaded in. Now only y to 0 is 1, so then the answer is 9x. Now negative 8 to negative 5 is just an expression which is negative. And we have 1 over a to the 5th power. So this is a, and then the power, and it's 5. And that's it. Here you have to apply the exponential rules. That's number 14. Yes, no?
Yes.
So 28 a to the 8th b to negative 6 over 4a to negative 8 b to negative 4. 28 divided by 4 is 7. A to the 8th divided by a to negative 8. Copy the base and subtract the exponents. Copy the base and subtract the exponents. But since this still has a negative exponent, it has to go to the denominator. And that's it. There is nothing else we need to do here. Any questions?
No, but thank you.
Thank you. Good. So here we have a division by one monomial, one term. If you simplify, that would be a terrible mistake. Do we need to work on this? So 24z minus 28y divided by negative 4y. The only chance we have is separate into two fractions. 24z divided by negative 4y minus minus will be plus 28y over 4y. So here I have negative 6 and z over y has to stay as is. There is nothing I can do, but here I have positive 7. And that's it.
That was z over y, not or y over z for that last term.
You mean this one?
Yes. The 28y to negative, or 28z. If you look at the question 15.
It's not possible because then we would have been able to combine like terms.
I thought it was 3 different variables.
I don't know if it's going to give me the same problem.
Oh, no, oh, I see. There's 2 y's. Never mind. Sorry.
No worries. This is a long division. We did it several times. If we need to do it again, we can do it again. This is a scientific notation. Yes, no?
6.4.
So it's 6.4 times 10 to the 9th. Okay, this is 4, and then we're followed by 6 digits. 3, 7, and 4 more zeros. In the decimal notation, I have 0.00846. Factor the greatest common factor. Yes, no?
Yes, please.
Okay. Eleven x squared y squared minus 22 x to the third y to the third. And the greatest common factor is obviously 11 x squared y squared. The smallest power for x is 2, the smallest power for y is 2, and 11 and 22 have a common factor of 11. So this is 1 minus 2xy. Whatever you write, just imagine you go back and redistribute it. You have to get this. Is this times this that? Yes, it is. And we've done this a lot with factoring by grouping. We always checked. This times this is negative 22. X squared times x is x to the third. Y squared times y is y to the third. Good. Factoring by grouping. Yes or no? Remember, from all strategies of factoring, factoring by grouping is the easiest. Then binomials, and then trinomials. Okay, is it a yes or no? Moving on.
Yes.
Okay, so AB plus 3A minus 2B minus 6. From the first two, I will factor out an A, and I have B plus 3. If I do not get a B plus 3 from the other two, I cannot continue. I have to go back and rearrange or refactor. Who knows? I don't know. But I have to get the B plus 3. And I have to have a sign and a factor. Oh, it's negative 2. Why? So then the common factor is B plus 3. And what is left is A minus 2. That's what I said. Factoring by grouping is the easiest possible. But if you remember these steps, because otherwise you can stay here and sit here and say, okay, what do I do now? What is that? What do I do to negative 2b? Oh, no. But if you write, as I said, if you cover it up or not look, and you write it first, it will save you a lot of time. Okay, p squared minus 9p plus 18. I don't hear anything. X to the 6th minus 12, x to the 4th minus 11, x to the 5th.
X to the 4.
Okay, 24. Okay, this is a difficult situation. This one. Why? I'm going to replace c by x. X squared. Why is this difficult? Because it's a trinomial. The leading coefficient is not 1, and the special product is not applicable here. So I have to find two numbers whose product is negative 36 and whose sum is 35. Remember, the next step is here. I look at the product. It's negative, so I expect a positive and a negative.
36 negative 1.
36 and negative 1. So now I have to replace this using these numbers. So I have 6x squared plus 36x minus x minus 6. And now I'm back to factoring by grouping. From the first two, I see a 6x, so x plus 6. If I do not get an x plus 6 coming out from the other two, then I'm in trouble. Oh, negative 1. I put it here because I've seen it. Students write x plus 6 times 6x. Oh, that's not possible. So it's x plus 6 times 6x minus 1. Don't enter anything. Just multiply them and see if you get the original problem. If you multiply these two and you don't get the original problem, then this is wrong. Okay, so this is a difference of 2 squares. The problem is still, it's already telling us what to expect or what to write. So this would be 3m squared. Exactly. First plus 2n, and the other one is 3m squared, but minus 2n. That's it. This is the difference of cubes. This is not an easy formula, but I broke it down for you, I think, easy enough for you to remember it. So we have w to the third minus 27. And we know it's in descending order, no leading coefficient, no negative leading coefficient, no common factor. So I know it's a binomial times a trinomial. The only thing I need to identify is the binomial, and remember the sequence of signs. Minus, minus, plus, or plus, not plus, minus. And of course we have w and 3. This is very easy because it's squared, and the product. Once I have the binomial, the rest is very easy. But we have to remember, you have to practice the pattern.
Positive is plus minus plus.
Yes, plus, plus, minus, or minus, minus, plus. Now this is a very simple situation. So we have 2x squared minus 17x equals 0. Always think in terms of the greatest common factor. So I'll factor out x, 2x minus 17, and I get two options, x equals 0 and x equals 17 halves. When the free term is missing, never use the quadratic formula, ever, ever, ever. Factoring is, will take 3 seconds, and you're done. Solve the quadratic equation by factoring. You have to subtract v first, and then factor. Okay, so here we have to solve this equation. Let's take a look. Negative 16 t squared plus 80t plus 70, of course, minus 166 equals 0. So I have negative 16t squared plus 80t, and then minus, is it 96?
Yes.
I will never ever solve a quadratic equation with a negative leading coefficient. That would be silly. Also, I hope I can get rid of this. I hope I can divide both sides by negative 16. If it works out, if it doesn't, then no. So this is t squared. This is negative 5t, and this is positive 6. Therefore, this is a piece of cake. And I get a t equals 2 and t equals 3 seconds. This is what we've been doing. So always simplify. Simplify, factor, always go to the bare bones. Can you solve this equation? Yes, of course. But why? When I can make it so simple. Okay, so here I just plug in this function in the graphing calculator in y equals. I clear, I put in what I have, and then second in table, and I put in all those numbers. This should take 30 seconds. It takes longer to plug this in than find these values. You don't have to do this by hand. And in 31, yes, we can talk about this again if you'd like. I remember doing
When
that.
you plug that into the calculator, does it give you the decimals as well, like 0.5, 1.5?
Yeah, thank you.
Of course. Of course, yeah. Yep. Okay, do we want to work on the last one?
Yes.
Okay.
This one confuses the crap out of me.
So a wire stretched from the ground to the top of an antenna tower. The wire is 17 feet long. Okay. So this one is 17 feet. The height of the tower is 7 feet greater than the distance d from the tower's base to the end of the wire. Okay. So this is d plus 7. Find the height. Okay, so let's take a look. So this is the top of the tower. And here is the anchor. We know that from the base of the tower till where the anchor is put in the ground, the distance is d. We are told that the wire is 17 feet long. We are told that the height of the tower is this distance from the base to the anchor plus 7 is 7 more. Let's check. Let's read the problem one more time just to make sure. Okay, so a wire is stretched from the ground to the top of an antenna tower. Fine. The wire is 17 feet long. Fine. The height of the tower is 7 feet greater than the distance d from the tower's base to the end of the wire. Good. So now they're asking us to find d. But we know the Pythagorean theorem. The longest side, which is the hypotenuse squared, is the sum of the squares of the two legs. If you don't get 3 terms here, then you have a problem. D squared plus 2 times the first times the second plus the second term squared. And what is 17 squared? So I got 289. So d squared plus d squared, 2d squared, plus 14d, plus 49, minus 289 equals 0. So 2d squared plus 14d minus 240 equals 0. Of course, I'm going to simplify and divide by 2. So d squared plus 7d minus 120 equals 0. You can use the quadratic formula now. Negative b plus or minus b squared minus 4ac over 2a. Do not attempt to take the square root from those. You cannot. It's a sum of terms. You cannot split the radical. So d equals negative 7 plus or minus the square root of 529 divided by 2. Now I know nothing about 529, so I'm going to read, type an integer or a simplified fraction. Of course it's in feet. Okay, so I'm going to look at 529. That's not what I meant. Wonderful.
Nice.
So then we have d equals negative 7 plus or minus 23 divided by 2. And although algebraically we have 2 solutions, negative 30 over 2. This is not acceptable because it's negative. And the other one is 23 minus 7, which is 16 divided by 2, which is 8 feet. So if the distance from the base here is 8 feet, so then the tower is 15 feet. How would you check? When you square 15 and square 8 and you add them up, you have to get 17 squared. Otherwise, something is wrong. So with the graphing calculator, 15 squared I know is 225 plus 8 squared is 64. That's not what I meant. 225 plus 64. And if I do not get the same thing with 17 squared, then I'm in trouble. So the sum of the squares of the legs, where the right angle is, has to equal the hypotenuse square.